Hello and welcome to another video. This time we're going to be looking at the pcf8575 chip. This is a 16-bit input-output port expander that we can add to our Agon. The module normally comes in a neat package with the i2c pins easily accessible on one side. And on the two main edges we can see the I/O pins. Pins labelled 0 to 7 are the first 8 bits. And pins labelled 10 to 17 are the second 8 bits, making a total of 16 input or output pins. Each pin can be configured to be either an input or an output. On the back of the module there are some solder pads so you can change the actual bus ID. For today's project we'll keep it quite simple. We'll have a button to provide an input and an LED to do the output. The idea of the code is to look at the inputs, and if the button is pressed, then light up the LED, and if it's not, then turn the LED off. We're only going to be using 2 of the I/O pins today, but I've kept the input on one side and the output on the other side for simplicity. Although I've used pin 0 and pin 10, it could easily be pin 0 and pin 1. For the input, pin 10 is connected to a switch. It then goes through a resistor and to the 3.3 volt supply. When the switch is pressed, P10 is made high. When it's not, it goes low. The output is done the same way as we did on our previous project, where we had the 8-bit I/O port. Here, the pin is normally high, and it matches the 3.3 volt supply. When we set the pin low, a current flows through the resistor and lighting up the LED. If we take a look at the code for our project, much of this you'll have seen before, so I'll only dwell on the bits that are relevant to this project. The first critical part is calling the configuration. When we set up the configuration for this module, like we did with the 8-bit I/O port, we need to tell it which pins are going to be inputs and which pins are going to be outputs. The only difference with this module is that we're going to be sending 2 bytes of data rather than 1. And here what we're doing is setting up the address, the number of bytes to send, and the buffer from where those bytes will come from. And in this buffer we're going to set the first byte as all 1s and the second byte as all 0s. That means all of the lower bits will be outputs and all of the upper bits will be inputs, although you could mix these as much as you like. Whenever we read or write data, we always send 2 bytes, and they go in the order of byte 1 is for pins 0 to 7 and byte 2 is for pins 10 to 17. So firstly, we read the buffer. We read 2 bytes and that will tell us whether any of the buttons have been pressed. Next, we're simply printing out a binary version of the 2 bytes which we received, so that on our Agon we can see what's going on. To keep things simple, I'm taking all of the buttons pressed and converting those and sending them out as an output on the lower bits. So first of all, we're reading what is the inputs, creating a complement of that so that any 0s are 1s and 1s are 0s, and then putting those in the first byte of what we're going to write back out again, and that will then be for the LEDs which get lit. We're then going to put 0 in the second byte. So that's just reiterating that the second byte on our module is going to be all inputs. We then send those bytes out, and that will switch on the LED or turn it off as appropriate. If we take a look at the code running, on the display we've got the inputs and the outputs, so where we've set all of pins 0 to 7 as outputs and all of pins 10 to 17 as inputs. And you can see at the moment all the outputs are high and the LED is not lit. All the inputs are 0, that means that no buttons are being pressed. We've only got one each of these wired up today for simplicity, but you could have a whole array of buttons and LEDs. So if we actually press the button, you can see that our input changes on that pin 10 and the output on pin 0 has been set low so that the current can flow through the LED. And that's as simple as it is. It's easy to read inputs from buttons or other sensors and to output a result such as an LED, or maybe you're switching on a relay or something else. Hopefully you can find a use for this module in your projects.